The good thing about relationship maps is that there aren't really any rules associated with creating them, so you can create just about anything you want to. The bad thing about relationship maps is there are essentially no rules associated with creating them. So it's the good and the bad. And because there are no rules, people create whatever it is that they think makes sense, and then they have to explain to other people how to actually understand the maps that they develop. If we use a set of well-defined conventions to develop our relationship maps or models, then when other people look at them, they already have a basis for how to interpret the map because there's a well-defined set of conventions under which they were created. Now, I'm going to introduce you to two notations. The first one is called the S and the O notation, which was introduced by Peter Senge in 1990 in the fifth discipline, the art and practice of the learning organization. If you think about the influence between two variables, there's only two types of influence that can happen. And the question is that if the influencing variable increases, what will happen to the influenced variable? And it can change in the same direction, the reason for the S notation. So if this increases, changes in the same direction. Or if this increases and this decreases, then it changes in the opposite direction. So it's a same and other notation. There's an older notation, which is a bit more difficult to understand because it's an overloaded definition, and I'll explain to you why in a moment. The influencing variable can add to the influenced variable, which means it's a plus, or the influenced variable can change in the same direction as the influencing variable, which is a plus. The alternative is that the influencing variable can subtract from the influenced variable, being a minus, or the influenced variable can change in the opposite direction of the influencing variable, again being a minus. So that plus and minus have two different meanings depending upon the types of variables or the nature of the interaction. And the reason that the overloaded definition actually makes more sense is because at certain times the S and the O notation produce absolutely erroneous interpretations of the diagram. Production, the creation of content or creation of product, adds to inventory. The nature of the plus sign makes sense. If production decreases, inventory doesn't decrease, it still continues to increase, just not so rapidly. So an S notation on this relationship would give the wrong interpretation of the relationship. And it simply has to do with the nature of inventory and the way that it accumulates, as opposed to being an instantaneous variable. So I prefer plus and minus as opposed to S and O. You will see that in almost all of my diagrams. And because adding the pluses and minuses just gets to be annoying in an environment that doesn't accommodate them naturally, the convention I use is I always use blue for pluses and red for minuses. And I don't typically refer to them as plus and minuses. I refer to them as adding and subtracting, because minus gives the connotation that it's negative, and it's really not a negative influence. It's simply a reducing influence. Now, since the intention is to talk about causal loop diagrams, there probably should be a loop here someplace. So if we look at this second diagram, if we're talking about adding and subtracting influences, there's essentially only two basic fundamental ways that you can connect them to create loops. The first one being where I have some action that creates a result, and that result promotes more of the same action that created the result. So it's a reinforcing cycle which is the reason that it's labeled with a snowball rolling downhill. It's reinforcing. The reason that you can tell it's reinforcing, to remember in the future, that there is no or a even number of subtracting influences in the loop. In this one there are none. In this, so it's a reinforcing loop. The other option is to create what's called a balancing structure, so that we have a target value and a current state, and it's the difference between those two which creates a gap, and the gap promotes action, an action intended to move the current state in the direction of the desired state, so that this tends to reduce the gap, while this increasing this tends to increase the gap. And what you ask yourself, if this changes, irregardless of all of the other relationships in the model, how does it influence the target variable? So if I increase the inventory, it tends to reduce the gap, and that's why it's labeled as a negative. So that if you follow this loop, there is one subtracting or negative influence in the loop, so it's a balancing loop as opposed to a reinforcing loop. And as I said, the pluses are additive or reinforcing, and the red ones are negative or balancing. Reinforcing loops always run into limits sooner or later. Nothing grows forever. And balancing loops always have a goal, and it's good to know what they are, what the goal is. What is it that the balancing loop is trying to bring balance to? So those are the two kinds of structures. Now if we take the awareness of those two types of structures and look at some of the models that we've already worked with, such as the manager's challenge, if we look at the first loop, there was a deadline and an expected completion date. The difference between those two resulted in overtime and labor quantity. Labor quantity reduced the expected completion date. So if we walk this cycle, it's positive, positive, negative. So there's one balancing influence in the loop, which means this is a balancing loop, and it's labeled B1, the overtime implication of the schedule gap. We look at the second loop that we drew from these two around to overtime to fatigue. Here is a balancing influence, another balancing influence. So there are two of them. There are an even number of these balancing influences, so that it's actually, this is a reinforcing cycle. It's labeled with a reinforcing element, and we'll talk about how to do that very shortly. And so it's labeled R2 as a reinforcing loop. The next one that we talked about was from here to add resources to a labor quantity, one balancing influence, so that there's only one balancing influence in this loop. So it's a balancing loop, and it's a resource addition loop. So the label tells me what kind of a loop it is, and it also tells me what the intent of that loop is, so that this loop is to add resources. The last loop, which was from schedule gap to resources, a balancing influence to labor productivity, balancing to expected completion, and back to the gap. There are two balancing influences in that loop, so that it ends up being a reinforcing loop, and it's a resource delay loop indicated to be reinforcing, and we call it R4. These loop indicators are done with what's called a picture variable. Create a picture, and with the internally defined images, you can select from this drop down. In other words, if you right click on this and go to picture primitive, and tell it to use the built-in images. Here are the clockwise and counterclockwise reinforcing loop indicators, clockwise and counterclockwise balancing loop indicators, and these are when the loop is indeterminate for some reason. So I could select this and label it as the clockwise balancing loop indicator. So you just create those and resize them and put a label on them that's appropriate for what it is that you're identifying. And now if we go back and look at this video is getting a little long, but if we go back and look at the essence of AND that we did, this initial loop, notice that there's one balancing influence, so that this is a balancing loop, and this is intended to be an insect control loop. The second loop that we did had to do with population growth, so it's a reinforcing loop and it's a population growth loop. The third one, which went from crop eating insects to crop damage to pesticide immunity and back to crop eating insects, is all reinforcing influences, so that this is a reinforcing loop and it's a pesticide immunity loop. The fourth loop, which went from crop eating insects to crop damage to apply pesticides to kill controlling insects, which is a negative influence, controlling insects, to crop eating insects, another negative influence. So there's an even number of balancing influences, so this is also a reinforcing loop, and it's a predator destruction loop. So by having those loop labels, simply by looking at the label, it gives you a quick sense of the intent of the whole loop and whether it's balancing or reinforcing. Here is a short description of Aesop's fable, The Boy Who Cried Wolf, unfolded as a relationship model, so that the boy wants attention and he's bored tending sheep, so he cries wolf, with the understanding that it'll cause the townspeople to come running, make him the center of attention, which will relieve his boredom. Though, if it were only that simple, if he actually wants attention, he cries wolf, and there is no wolf, it represents a lie, which reduces the beliefometer, which ends up reducing the likelihood that the townspeople will come running and make him the center of attention. Though if the boy cries wolf and there is a wolf, it represents a truth which increases the beliefometer, which increases the likelihood that the townspeople will come running, making him the center of attention, relieving his boredom. So overall, there are 3 loops in this structure, and the structure makes sense in terms of an unfolded story. Though if you go ahead and add the indicators to it, it's apparent that this first loop is a balancing loop, it's a boredom relief loop, while the second loop is a reduced belief, and it's a vicious reinforcing loop because it doesn't accomplish what he wants to accomplish. And the third loop is an improved belief loop because it contains truth, and there is just one balancing influence in that loop. So the idea of causal loop diagrams is that they make the model that you develop much easier to interpret. It takes a little bit more time and thought to develop them, but the payoff is that when you attempt to unfold them as a story to someone else, they contain much more meaning. So hope you found this useful, and I'll see you in another video shortly.